Hello everyone, today we're gonna solve a new LeetCode problem. Today we have a problem number 2385, amount of time for binary tree to be infected. It's a medium problem for trees. You are given the root of a binary tree with unique values and an integer start. At minute 0, an infection starts from the node with value start. Each minute a node becomes infected. If the node is currently uninfected, the node is adjacent to an infected node. Return the number of minutes needed for the entire tree to be infected. Okay, here we have two examples. Like we have three. Okay, they are all unique. We have three. Then 10, 6, 1, it's a first. 5 second, 4 third, 9 2 fourth, and we have output fourth. Okay, if we have a single root, just single node and its root, then we have 0 because if it's matched with start. A node with a value of start exists in the tree, should not have any value. Okay, from 1 to Probably we can start from if root left equal to null and root right equal to null and root value equal to start, we just return 0. Otherwise, here will probably some DFS root start, or even we can probably even move start somewhere here. And here will be our DFS, or okay, well, maybe there is no need to hurry up. Okay, first of all, we need to find this node from which we're gonna start. It will be log n because it's a binary tree. Okay, it's not a BST. They are all messed up. Okay, it's ON to find start node. Then we have to build a map with nodes that has their parents, like node 3 has parent 1. Then we start from nodes that are start, it's a 3. And then we with BFS, we check every level around our start node and count minutes. And total time complexity will be ON to find, then ON to build, and then ON to go through. Okay, total will ON, and for external map for starting parents, it will be ON2 and pass stack. So it's ON probably. Okay, I will check it later. For now, it's ON. Maybe ON plus M. because of start. Okay. So first of all, we need to find values that we are looking for. It will be our like 3-node start like node. Here we have to go like 3-node search start, 3-node root start. If root, better to call it node. If node equal to null, we just return null. If node value equal to start, then we return node. And do the same for left. And right. And here if this one not equal to null, okay, I have to store it somewhere. Something like this. And here start will be this. Then I will probably have some BFS for 3-node. Node and 3-node start and some parents. I will build parents method to click node. Here I will have map with 3-node parents new hash map. Here I just go through if not equal to null, return, and here, and I probably need 3-node parent. Build parents root now. If or just parents put node parent, and the same for left and right. Okay, and finally, we have to count in BFS from start node, and that's all. It will be integer. Minutes 0. We probably have to add some scene array for okay, probably we can just use some array list of 3 nodes. Then we have to create a queue of 3 nodes. Add to this queue our start node. Add to scene our start node, and then while our queue is not empty, we take its size of current level of our tree. Okay, let's move minutes closer to our loop to see it. Then we go through usual loop from 0 to n, where we pop element from our queue. And if element left is not null, we add it to our queue in the same but with right. After this, we increment our minutes that return minutes. Okay, let's see what's going on here. Okay, output 2 instead of 4. One, two, three, 4. Okay, yeah. Here is one mistake. When I go through this loop, I have to go through inner I have one more loop to have some variable like subnode, and it will be 3 nodes array. It will be okay. Let's see. Yeah, I will add here left, right, and from my parents map I will get a parent by element, and here I have to add it to scene, this subnode, and to queue. Subnode, okay. And before this, I probably have to check that my scene does not contain this element. and element is not equal to null. Or even you can just simplify it. Do not overcomplicate my if here. Just check it here before adding to the queue. Okay, here I have. Yeah, because I need to check subdom. Memory limit exceeded. Sorry. Some work stuff. Okay, memory time exceeded. Because I didn't check here. Now I have output 1. Okay. So we have. I start from. Sorry. Is it really 3 or I just think that it's 3? Yeah, it's a 3. We start from 3. Add it to our queue. Yeah, okay. I check it. Okay, then I can't simplify it here. I just have to check it here. So something like this. Now I have 5. And I have 5 probably because of what? Because because of what? I go from 3 and add it here. And 3 counts to. Okay, maybe I have to start from -1 just to simplify it. And time limit exceeded for. And how I can debug it? Oh my god. It's not possible to debug it. So it passed. "69 test cases, just 11 left. Or maybe I have to check some. Convert the tree to an undirected graph to make it easier to handle. Use BFS starting the start node to find the distance between each start. The answer is the maximum. The maximum distance. Okay, I already used BFS. Maybe I have to convert it to undirected graph. I have no idea how to convert it from tree to undirected graph. I will check editorial because I don't know how to do it. To convert to undirected graph, we will have current, parent, map. Okay. Okay. Just a list of nearest elements, and we recursively go through our tree, left, right, then to the list. To set. And if map does not contain this and the full solution will look like convert map convert q bfs visit and then go through while. Okay, in this case we don't have this sub. We have sub. I just used 4 here, so we still have 3/4. But because of we are going through the map, and check all the nearest elements, it's faster because we don't. Okay, where we have started. We start from the start. And because we have it in our map, we don't need this extra line of search start. Pretty smart. At least time complexity and space complexity, I define it right. Okay, we'll try to replace the search start to the convert. So I need some current. One more time, current parent. Current is our node, parent is our parent. Okay. Parent and hash map of integer, I guess, and set of integer. It will be our map. And then we get rid of this and get rid of this instead of we use convert our root 0 and some map. I probably can store it here, call it graph, and instead I will have this. Okay, now I have the right map. And I don't need parents anymore. Just a single line. Okay, I'll update BFS later. Now I have to delete build parents. And start node, I don't need. Okay, if current not equal to now, here we void. We just return if graph contains key current value, not contains. Then I had graph put current value new new what? Okay, new hash set. New hash set of integers. And then some list of just list that I will take from the same graph by current value. Here I have to check what I have to check. If it's a root node, then our parent should be not equal to 0. Then we can have something like this. Here, if left not equal to now, and I will have to add current left value. The same for right. And just convert current left, parent, current, val, and our graph, or just pass map or further. Or I don't need to pass it. I do this. Just this two. Yeah. Looks correct. Yep. Just here is right. Okay, I did convert. Now I have to change my BFS. Here is will stay everything. It's from start. Here will be integer. And now I have to change it to integer and q integer 2. Add it. Okay, let's do it like this. Now I remove this element. Here will be, instead of this, I just take graph get element. I will take adjacent nodes. Now I don't need to check that it's not now. And just add it to C and Q. Let's check it. Time limit exceeded. Interesting. Not contains. Convert looks good. Root 0. C and Q. Get from graph. Hash set then. And the value. Count. Strange. Everything should be fine. But still time limit exceeded. Is it possible? At least so. Do I have a map? Convert it to create a queue. My queue is not empty. Level size. Go. This level size. Remove my element. Get it from map. Check if it's not contains. If it's contains, then skip it. Everything looks the same. Really strange. Okay, let's remove this one. test case and check on these two simple ones. Yeah, this two works fine. So tutorial give me wrong pass. It doesn't work. Okay, let's try to simplify it even more. Move our map here and pass it here and here, and I will have this and this step again. I could pass here and here, and then I need to add it to my BFS. Check it, right? Yep. Okay. Just to make sure that it's a problem with my code, not with the total editorial solution. Yeah, okay, here it passed with very, very bad result, but still. I guess there's some stupid mistake that I can just find. Of course, I will mark this task as not solved, but still just interesting for me. What's wrong and how I can finish it. Hmm. Okay. So I think it was pretty interesting and not solved. Thank you for watching.